Welcome back to Strength of Material Lectures by Civil Thinking, and this is our another class on bending stress in beams. As you know, in the previous class we have found the equation of bending stress. E divided by R is equal to sigma divided by Y is equal to M divided by I, right? Now in the previous class we have proved E by R is equal to sigma by Y. Please watch the class first of bending stress equation derivation part 1. You will know where did this came from. Okay, I can explain it. Let's consider this is a beam. Okay, you can see a load is applied on this beam. This is the neutral axis of the beam, and I have considered a layer. Let us say the layer is PQ. Okay, this is another layer, longitudinal layer, and when you apply the load, it bends into a circular arc, right? It bends like this. Okay, it bends like this, right? Now of course this bend, it is a circular arc, therefore it is a part of something big circle. Okay, because that is the assumption of theory of pure bending. Now we know in the previous class we have found the stress on this PQ, okay, which is sigma by Y is equal to E by R. Okay, now it means sigma is equal to E by R multiplied by Y, right? This is the bending stress on this PQ layer, which is at a distance of Y from the neutral axis. And also you can understand from here, this is the neutral axis and PQ is at a distance of Y, right? Y from the neutral axis, and the bending stress on this PQ layer is sigma is equal to E divided by R multiplied by Y, right? Now this is the stress. Now because of the stress on the PQ layer, of course there will be forces on the PQ, right? Because force is what? Force is stress multiplied by area, right? So we can say let the force on this PQ layer be F, then force will be sigma multiplied by area of PQ, right? Now let us say area of the PQ is dA, therefore force on PQ is going to be sigma multiplied by dA, right? Now let us find the moment of this force. Okay, we have a force acting here on PQ, and we can find the moment of this force about neutral axis. Okay, so we can find moment of force, force on what? Force on PQ layer, right? About neutral axis, neutral axis. Okay, now if you don't know about what is neutral axis, please watch my previous video on neutral axis. I have explained that very well. Okay, now moment of force. Now moment is what? Moment is force, and the force is F, right? This is force multiplied by distance, right? We have to find this is the force here, and we have to find its moment about neutral axis. So we have to multiply force multiplied by Y, right? Because Y is the distance between neutral axis and PQ. So it is going to be Y, right? Now force is sigma multiplied by dA. So I can write sigma dA multiplied by Y, right? Now we know sigma is the bending stress on PQ layer, which is E by R multiplied by Y. So here I can put E by R multiplied by Y. This is dA and this is Y, right? Now this is E divided by R. This is Y square dA, right? When you integrate this is the moment. What is this? This is the moment of the PQ layer about neutral axis. Now when you integrate this, okay, integration will give you the moment of all the layers like PQ. Okay, all the layers like PQ, like here is one layer, here is another layer, all of these layers, right? The integration will give you movement of all the layers, okay, all the fibers about the neutral axis. Okay, and the movement of all the layers or movement of all the fibers about the neutral axis, that is known as movement of resistance. Okay, so I can write here, so let me write here movement moment of resistance. Okay, it is equal to integration of all of this, right? Now let us say the applied moment, okay, is m. We have applied a moment on it, or we can say the load has applied a moment m on this. Now for the static equilibrium, the moment of resistance must be equal to the moment, okay, only then it will be in static equilibrium. Okay, so we can also write m is equal to this, right? E by r y square dA, right? Now E by r, okay, they are constants, they can be taken out of the integration, so I can write something like this, integration of this, right? Now we have this term, integration of y square dA, integration of y square dA. What is this? Now if you have watched my video lecture series on uh, center of gravity and moment of inertia, okay, you will understand this integration of y square dA is the moment of inertia, which is denoted by I, or area moment of inertia of the section of this beam. Okay, now you can see here, this is the beam, and let's assume it have a rectangular section, something like this. Okay, now this is the neutral axis. Of course it will be like this. This is also the neutral axis, right? This is the neutral axis. Okay, now here is the layer PQ, so it is going to extend in the cross section like this. Okay, this is also the layer PQ, right? This is the PQ layer, and it is at a distance of y, right? So it is something like this. Here is neutral axis and A, and this is PQ layer, right? It is at a distance of y. Okay, now we did this integration of y square dA. dA is what? Area of this layer. Okay, now when we integrate it, it will give the second moment of area, right? Y square dA, second moment of area of all the layers about neutral axis. Okay, this is moment of inertia about neutral axis. Okay, again, if you don't know about the moment of inertia, please watch my video lecture on moment of inertia. Anyways, now we know integration of y square dA is I, which is moment of inertia or area moment of inertia about the neutral axis. So here we can replace y square dA integration with what? I, right? So if we rearrange this, what we get? We will get m, let me take I down here, m by I is equal to E by R. Okay, now in the first class we have proved E by R is equal to sigma by y, right? Now here is m by I is equal to E by R. Okay, here is also E by R. Now m by I is equal to E by R. Okay, and sigma by y is equal to E by R, right? It means E by R is equal to sigma by y is equal to m by I, right? Because m by I is equal to E by R, and sigma by y is also equal to E by R, right? So when we equate these two equations, we will get m by I is equal to E by R is equal to sigma by y. Basically I remember it like this: m divided by I is equal to E divided by R is equal to sigma divided by y. Okay, now this is the complete bending stress equation. Okay, this is really important and you must remember it, and you will be able to solve a lot of problems on this bending stress equation. Okay, again, if you need the PDF of this video lecture, as always, you will find it in the description, the link in the description. And if you have any doubts on this video lecture, please contact me in the comments and I will definitely help you. And that's it for today. See you in the next class. Thank you.